Today we're going to talk about the normal distribution. So we are going to look at variables with symmetrical bell-shaped distribution curves. These curves are what we call a normal distribution, and it arises in situations when many different factors can affect the value of a variable. For example, consider the test grades of a class. All of the grades will not be the same, and this may be due to factors such as study time, completion of assignments that lead up to the test, whether the student asks for help, etc. The result is that most of the students will have grades that will be centered around the mean or the average, and that there will be fewer grades that are way below and fewer grades that are also much higher than this mean. So now let's talk about the normal distribution curve. So although all normal distributions have the same general bell-shaped curve, the exact location and the shape of the curve is determined by the mean, which we denote as the Greek symbol mu, which represents the center of the distribution. And we also look at the standard deviation, which is represented by the Greek symbol sigma, which represents the spread of the distribution. If x is normally distributed with a mean and a standard deviation, we write x is distributed normally around the mean and the standard deviation squared, where m, which is mu, and your sigma, which is your standard deviation, are the parameters of the distribution. The probability density function of x is going to be called the normal distribution curve, or just the normal curve. So let's look at example 1. We want to sketch that x is normally distributed about the mean of 3 and the standard deviation of 2. So we already know that 3 is my mean or my mu. And we know that 4 is the standard deviation. So normally we write our mean in the center. So we're going to write 3 here. And then we go up and below by 4. So we're going to have 3, then we're going to have 7, then we're going to have 11, then we have 15. I'm going to go the other way. We can have -1, -5, and -9. So that will be the general sketch of my normal distribution curve. So all you do is draw your bell-shaped curve, you label the mean in the center, and then you use your standard deviation to scale that axis. So now let's talk about calculating probabilities. For any population that is normally distributed with a mean, mu, and the standard deviation of sigma, approximately 68% of the population will lie between 1 standard deviation below and 1 standard deviation above the mean. So I'm talking about these areas in between here. So this 34.13 on both sides. Then it says approximately 95% of the population is going to lie between 2 standard deviations, so including these next 2 sections on either side. That's 95%. And then approximately 99.7% will lie within 3 standard deviations of the mean. Okay, so that is what that means here. And you can always use this chart to see your percentages. So let's look at example number 2. It says, Mrs. Roberts gave a test and the mean was 71% with a standard deviation of 6. State the proportion of the grades that were between 71 and 77%. And we want to also state the proportions that were less than 65%. So the first thing we want to do is we want to draw our sketch. So the mean is 71. So I put my mean in the center. And then my standard deviation is going by 6. So that means I increase and decrease by 6. So 1 standard deviation above the mean will put me at a grade of 77. 2 standard deviations above the mean will put me at 83. And 3 standard deviations above the mean will put me at 89. Then I'm going to go back to the other side. 1 standard deviation below the mean will end up putting me at 65. And then 2 standard deviations below the mean will put me at 59. And then 3 standard deviations below the mean will put me at 53%. So now it says we want to figure out how many students are going to have between, or the population, or the percentage, excuse me, that is going to be between a 71 and a 77%. So if I want to figure that out, I want to figure out the probability from 71 to 77. So I want to find this percentage of this value here. And we already know that corresponds to 34.13. So that's what we can do. We can say that that is approximately 34.1% in 3 sig fig. If we want to find that the values are less than 65%, we want to mark where we have 65 and we want to be lower than that. So we want to find this area under this curve here. So if you realize that, then you should notice that we're going to start, the 65 is located 1 standard deviation below the mean. So 65 is corresponding to the mean minus 1 standard deviation. So I'm going to be looking at the 13.59, the 2.15, and then the 0.13. So I have to add all of those up. So when I add them, I will end up getting the following. 0.13 plus 2.15 plus 13.59. I end up getting approximately 15.9 in 3 sig fig. All right, so now let's look at number 3. The hip measurements of 18-year-old female volleyball players are normally distributed with a mean of 39 inches and a standard deviation of 7 inches. Part A is asking, from a group of 250 18-year-old female volleyball players, how many would you expect to have a hip measurement between 25 and 53 inches? So, of course, we need to label this. So we said that our mean is 39 and my standard deviation is going up and down by 7. So if I do 39 plus 7, it will land me at 46 for 1 standard deviation above the mean. And then if I add 7 again, it's going to give me 53. That's 2 standard deviations above the mean. And then if I add another 7, it's going to put me at 60. And that's 3 standard deviations above the mean. So now I need to go back to find my standard deviations below the mean. So 39 minus 7 is 32. Subtract 7 again. We end up with 25. Subtract 7 again. We have 18. So it says between 25 and 53 inches. So I need to find from 25 to 53. So we're trying to find the probability of everything on the inside of here. All right. So if that's the case, then we should already know. Remember, we can refer back to this value here. So for these values, remember, we are looking between two standard deviations within the mean. So if I look at my mean, I go down 1, 2 numbers. So I'm looking from here to two standard deviations above here. So that means I'm adding up 13.59, 34.13, 34.13, and 13.59. So if I do that, I'm going to say that my total probability would be equal to 95.44%. So if we want to figure out the total number of people, we could just take 250 times 95.44% as a decimal. And that gives us approximately 238 volleyball players that fall into that category, which is majority of them, okay? So now, part B says that we want to find the value of K such that approximately 16% of the hip measurements are above K inches. So we already know all of the numbers under our normal distribution curve should add up to 100%. However, if I say that I only want 16% of the measurements to be above K, then that means that I want to shade somewhere over here because I only want 16%. If I shade somewhere, if I say above, if I say that, okay, this is the value of K and I shade here, that is way more than 16% because from the half point of the curve until the ends is 50%. So I'm going to rewrite my numbers here. And then we're going to draw it out. All right. So they say they want 16% of the measurements to be above K. So if I go back up to my general form here, if I say above K, then that means I want to be that amount or greater. So I want a shade going to the right. So I'm going to add 0.13 plus 2.15 plus 13.59, which is 15.87, which is approximately 16%. Okay, so because we added those values, we should be able to tell that the probability that we are speaking of here, since this value or the probability of this is approximately 16% here, that the value of K that we will be looking at is 46 inches. So now let's talk about using technology. So whenever you use technology, you have to press second vars. And then when you press second vars, you are going to go to normalcdf. So when you are doing this, it's going to ask you for your lower bound, your upper bound, your mean, and your standard deviation. So if your probability, if you're trying to find a probability that X is less than a number, that means that I can have the upper bound as that number, which we're going to say is K here. And then our lower bound is going to be negative infinity, which we represent as negative 10 to the power of 99. If you are trying to find a probability that X is in between two specific numbers, then the lower number is going to be your lower bound, and then the higher number is going to be your upper bound. And then if you are trying to find the probability that x is greater than a number, then that means that that number is going to be the lower bound in positive infinity, which is represented by positive 10 to the power 99. That is going to be your upper bound. So let's do some examples. Example 4, it says, the variable x is normally distributed with a mean of 46 and a standard deviation of 13. We want to find the probability that x is going to be between 42 and 61. Okay, so our lower limit is going to be 42. Our upper limit is going to be 61. So if we were to put our mean in, that'll be 46, and our standard deviation is 13. So when I paste it in there, I end up getting that my probability is 0.497 in 3 significant figures, or we can call it 49.7%. If I want to find the probability that x is greater than 54, when I press second vars, go to number 2, I know that my lower bound is going to be 54 because I want x to be greater than 54. And then my upper bound is going to be positive infinity, which is 10 to the power of 99. Leave the standard deviation mean the same. And we end up getting 0.269, or you can say 26.9%. Then we do second vars again for part C. And here it says we want to find the probability that x is less than 27. So that means I want to be 27 or less. So that means that my lower bound is negative 10 to the power of 99 because I can get as low as I can. And the highest I can be is 27. Leave everything else the same. And I see that my probability is 0.0719 in 3 sig fig, or I can say 7.19%. All right. Last but not least, example number 5. The days taken by professional gamers to complete the story mode of Call of Duty are normally distributed with a mean of 23.9 days and a standard deviation of 4.4 days. Calculate the probability that a randomly selected gamer will take at least 37 days to complete the story mode. So I'm trying to figure out what is the probability that the time will be at least, that means greater than or equal to 37. So if I go to second vars, normal distribution CDF, I know that my lower bound is going to be 37 and my upper bound is going to be positive infinity, 10 to the power of 99. I know that my mean is going to be 23.9 and my standard deviation is 4.4. So when I put that in, I end up getting that the probability of this happening will be approximately 0.00145 in 3 significant figures. So now part B, it says, out of 20 randomly selected gamers, 12 or more of them, what is the probability that 12 or more of them will take at least 37 days to complete the story mode? So this is binomial distribution because you're talking about out of 20 gamers, you're looking at 12 or more of them that took that took 37 days to complete the story mode. So remember, this is a binomial distribution. So this is saying that x is distributed binomially or as a binomial distribution when we have the number of people is 20 and we have the probability of success. Now remember, the probability of success is that it's going to take at least 37 days. And the probability of that is going to be 0.00145. So when we put this in the calculator, we are trying to figure out the probability that 12 or more, so x is greater than or equal to 12, But remember, the calculator does not do binomial CDFs. It does not do it with the greater than. It does it with less than. So we have to equal this to saying 1 subtract the opposite of being greater than or equal to 12, which is the probability of x being less than or equal to 11. So when I do that, I go to second vars. I'm going to go to binomial CDF. The trials is 20 because that's the number of people that I can complete the test with. The probability of success is 0.00145. The x value that we're looking at, we said 11 or less. When we put that in, we get 1. So this is equal to 1 subtract the probability that 11 people or less will take 37 days or more, which is 1. And 1 minus 1 is equal to 0. So there is no possibility that this will be able to happen. 0% chance that this will be able to happen. All right. So if you have any questions, please reach out to me. I do not mind helping you all. Have a great day.